Welcome to Voice First Multilingual Bots by Kelsey Krause and Melissa Sanson-Fauteux. This is our roadmap for today. Let's first see why virtual assistants should learn to speak new languages. We work on WebEx Assistant, a virtual agent designed for the business environment in a shared space. When booking a meeting room or starting a video call, a user can use their voice to perform a task that otherwise would need a physical button press or manual navigation through a graphical interface. Other times, the user is looking for a quick, human-like social interaction with the assistant, where the goal is more to mimic conversational norms rather than perform a particular task. That's where the user might ask questions about the assistant's background or ask how it's doing. Both kinds of interaction with the assistant are important. To meet user needs, we need to have technology that provides a meaningful service to our users, as well as build trust and expectations around our product. At their conception, every voice assistant is made in a specific cultural and societal context. The WebEx Assistant was first designed as an English language agent, but it was very clear that the development of this product could not stop there. In order to give access to the maximum number of users, the assistant needed to speak multiple languages. When we look at the demographics data for internet usage across the world, only about 25% of internet users prefer English content when browsing the web. English is often treated as the assumed default in language technology. It functions as the language of business communication in many contexts around the world, amongst many people whose mother tongue is not English. But the economies of English-dominant regions only account for about 20% of global GDP. In our view, a language-dependent product does a poor job of serving most of its potential users if the product are not well adapted to multiple languages, especially for voice interfaces where the user dialects and accents can easily affect the experience. But internationalization is not a simple translation problem. Introducing a voice assistant into a multilingual context or in a culture that is not your own requires an attention to sociocultural aspects of language use and interaction. We need to adapt the data process and algorithms of the underlying systems, but we also need to maintain a common infrastructure and interface design that accommodates those differences. This encompasses the kind of changes necessary for internationalization of a graphical UI, such as string length for languages like German that can form complex ideas written as a single word, and script directionality for languages such as Arabic or Hebrew, which are read from right to left. This also extends to considerations of typical speech recognition errors, the grammatical flexibility of voice commands, the reliability of script-to-sound correspondences in the writing system, and the personality of the voice replies and natural conversation styles in each culture. Even selecting the languages we work on requires a good understanding of what a language is and how the people who speak it identify with it. If we base our training data only on an official standard of a language, for example, taking data only from written sources or official documents, we don't serve our users well. Regional and sociolectal differences exist, and the idea of one standard language is an oversimplification. What most consider a language is really a spectrum. For example, Spanish as spoken in Spain differs from how it's spoken in Mexico or Argentina or Nicaragua, and our training data must reflect this. Our users are diverse, and we need to be sensitive to nuances of language so everyone can be understood and given access to the same resources. As the architects of the system, the choices we make can influence these considerations. So let's start with our first set of challenges. Let's talk about gender and language use. Designing conversations with the assistant in English uses fairly straightforward language. English does not generally require special verb or noun forms when talking to someone. And there are no markers of formality and no mandatory gendered language. In some languages like French or Italian, grammatical gender agreement is necessary. This means that depending on who is being talked to, a speaker will need to change the word according to the noun it refers to. In French, for example, the grammar constrains the speaker into specifying the addressee's gender in some contexts. In English, we're used to doing this when we talk about someone in the third person with pronouns like he, she, or they. But in French, if the addressee identifies as male, the speaker will need to use one form of the adjective, and another if they identify as female. This presents a challenge, especially when creating a voice assistant's replies, since in our context of shared meeting rooms, we cannot know the gender of the user who has started the conversation. Most English products choose to design responses where the gender of the user is never specified. We can avoid choosing between he or she by using the neutral they. If we're asking about whether someone is free to schedule a meeting, the assistant can reply, "I will access their calendar." But many languages do not have go-to neutral pronouns. And languages where verbs are also marked for gender have even fewer options. In languages like Hebrew, every conjugated verb is marked for gender, even with the first person, the English I. In the example here, there's a difference in the verb form based on the gender of the speaker in the sentence, I call. Ani mitkacher or Ani mitkacheret. The more forms of a gender expression that the grammar of a language requires, the more we have to make decisions about if and how we address the user. Similarly, many languages have formality markers that indicate the relationship between the speaker and the listener. You might use the familiar form of address with family members and friends, but switch to the formal style around colleagues or people you don't know. This is another challenge in designing interactions with a virtual assistant. If we misjudge the formality level that a user assumes between them and the assistant, those conversations can lead to poor user experiences. And in the worst case, the user can feel as though the assistant has disrespected them. In English, we can indicate politeness by making sure we address certain people using sir or Mrs. or doctor, for example, but we don't need to. You can do this in French as well, but another politeness marker is included on the verb in every sentence where an English speaker would use the word you. The example on the left shows the formal and polite style, comment allez-vous, while the example on the right, the informal, comment vas-tu. This means that a voice interaction designer also has to select a level of familiarity for any interaction between an assistant and a user. All of this really depends on the user's expectations, as well as on societal acceptability, which varies between regions, contexts, and generations. Navigating the complex social web of politeness in Japanese is another tough problem when we're dealing with a virtual agent. Japanese makes further distinctions. Let's look at a simplified example. There are different ways in Japanese to use the pronoun I, and this is very socially dependent. As we can see from this table, a speaker needs to be aware of gender identity, whether or not the spoken context is casual or formal, and the relationship between the speaker and the addressee. And this isn't even the entire system. Japanese also has verbal suffixes and conjugation that can also express respect, humility, politeness, or formality. And this is not just Japanese. Korean, Vietnamese, and many more encode gender and politeness into their systems in a way that is just not there for a language like English, or even French. As mentioned before, we cannot know the user's gender or the level of formality they assume when talking to a virtual assistant. We need native speaker linguists who are sensitive to these facts to rephrase any response that contains gender marking so that we can build a product that is inclusive of everyone.
So I'd like to talk about a second set of challenges, and those are the ones that surround spelling and language policies that different languages put into place. French is a language that has been very strict about its language policies. The language even has a governing body called the Académie Française, which introduced a spelling reform in France and other Francophone states in 1990. But those weren't without controversy. There have been many debates about these reforms ever since their introduction. Some of the rules were meant to standardize the way things were written on a page, for example, with numbers needing to have hyphens between each of the individual words to indicate their relationship to each other. Other reforms were meant to represent sound pattern shifts from older varieties of French into what the language is today. Many of these changed the spellings of words with the hope that the spoken to the written correspondence would be clearer. But these rules are now being used differently and unequally. In France, the reform is the official recommendation, but in Quebec and other parts of Canada where French is spoken, both spellings can be used. In our context, the assistant responses and the user queries are displayed on the screen like we see here. And because of this written modality, choices have to be made regarding the spelling of some words, and those choices are not neutral. This table shows some French words that could be written differently depending on whether we apply the spelling reform or not. Because many French communities have been so hesitant to conform to the spelling reforms, both choices are possible, as long as we're consistent within the system that we choose. Languages also borrow words from other languages that they're in contact with. What differs from one linguistic context to another is the perception of those borrowed words. This perception strongly depends on the socio-political relationship between the groups of the borrowers and the lenders. In a tech context, we see a lot of borrowings from English. And in a sentence of Italian or Japanese, there's no value judgment attached to that borrowing. It's often seen as necessary, as long as the language doesn't have an equivalent term. In France, similar borrowings are frequent and they're not perceived as a problem. But in Canada, where the French-speaking population constitutes a minority of the country, the introduction of an English word is not perceived as a neutral act. This is especially the case on national TV broadcasts, in teaching, and in the context of a product like a voice assistant. In Quebec, there are sets of laws to ensure that the representation of French is always bigger or more prominent than other languages. And this is true for street signs, the percentage of songs played on the radio, and any official publication. Linguistic political bodies work to develop an equivalent terminology for tech word borrowings, with different levels of adoption. Video conferencing now constitutes an essential part of our lives, and with it comes its own set of terms that were, most of the time, first defined in English. This is a question that is broader than just the language policies of Canada. These terms pose a challenge to localization as well. Needless to say, English product designers do not have to worry about these borrowings from English, but as products expand to other languages, it's clear that these kinds of decisions that are made can have large implication on a user's perception of the final product. The last thing we want to talk about today are some of the more general resource and technical challenges that we encounter in internationalizing a virtual assistant. We have 3 major hurdles that we face when we're internationalizing a virtual agent or chatbot. The first has to do with our dialogue management, which encompasses how we evaluate the scope and intended use of our assistant, as well as how it will present itself to others. There's also the challenge of data development, which we use to gather information about how users will interact with the assistant. This includes what kind of language they'll use, and whether this is different from the kind of language we might use with a human conversation partner. And we also look at resources beyond our language-specific questions and talk about how the limitations on machine learning and natural language processing tools can affect the quality of a multilingual assistant. We use the term dialogue management to talk about the design of the different dialogue interactions between the user and the voice assistant. This process is varied, but it can be more or less scripted depending on the application. But given the challenges that each individual language can present in terms of politeness and required forms of address, this is something that we cannot afford to overlook. And as we've talked about before, languages are strongly tied to the cultures, societal norms, and practices of the community that they're a part of. When we introduce a dynamic conversational component like our assistant to a user interface, this immediately brings with it those sociolinguistic and sociopolitical considerations that static content like a web page or an article in a magazine relies on much less. We need to control the quality, the regularity, and the exactness of utterances directed at users. And knowing how the assistant fits in with the social hierarchy of its usage context can be a big factor in its eventual design. If we build in a user experience that doesn't foreground the cultural or societal expectations of our users, we're not really serving those users to the best of our ability. In addition to being aware of the way the assistant responds to a user, a voice assistant also needs to be trained to recognize a wide variety of language styles. It needs to see varied input data in order to learn the nuances of the language, which means that when we build our training data, we want examples that are representative of the way people will actually speak to the assistant so that the model can learn to predict these kinds of patterns that are typical in the language. But using English as our baseline can make this seem like it's easy. For example, it has relatively little inflectional morphology. We do have different word forms that can vary depending on things like plurality, so that's the difference between cat versus cats, and on things like subject agreement and verb tense or aspect. English also has a pretty consistent word order, which makes coming up with training examples that are representative of how real users might speak a fairly straightforward task. For example, there are a few different ways that English can manipulate a single sentence to express a simple command to turn on a device's audio. And for this one, we can produce 4 sentences with 6 different word forms and various positions of the arguments. For a language like German, which has much richer morphology and a freer word order than English, the same sentence can be expressed in 24 different ways with 17 distinct word forms and varying word order. Remember, English does that with 6 word forms. This means that we need to be much more careful when curating data, and we'll need to include more training examples in German to cover the variation that's possible in the language. We also want to touch on some of the challenges that we face from a resource standpoint. Some of these can be mitigated by the NLP and machine learning tools that we choose to use, but not all of them. In recent years, natural language processing has seen major advancements in various language tasks, and there have been large performance gains in deep learning models. And with advancements like ChatGPT, allegedly, this opens up language generation possibilities to 95 languages, though there are still some performance issues. Through a little bit of our own testing and with some reporting done by non-English news outlets, it's clear that even these state-of-the-art language models are focused primarily on English, and specifically on US American English sources, and they rely heavily on translation. This means that even with these technologies, we need to be very wary of their outputs when we're deploying them in multilingual and multicultural spaces. When looking at other state-of-the-art language models, it's clear that these too have a smaller scope than we might be led to believe. The vast majority of machine-learned language models only focus on gathering and training data for a handful of high-resource languages, with a special focus on English. In reality, this means that the gains that are reported for deep learning models really only extend to English and a few other languages. What this means is that other languages with billions of speakers are effectively excluded due to a lack of large-scale data and to a focus only on improving those high-resource languages. This intense focus on English has created a huge disparity in the amount of cleaned, labeled data available to train non-English language models. And in fact, the availability of labeled data drops off drastically from languages that have the highest speaker population to the lowest. In plain terms, this means that only about 30% of the world's population has access to the technologies using large language models in their native language, those languages that are in the very high category in this table. And in language accessibility terms, this means that only a handful of the world's thousands of languages are currently benefiting from machine-learned technology. Data gap between high-resource and low-resource languages presents a challenge for internationalization efforts for a virtual assistant because models and feature sets don't always translate well between languages. English assistants can be trained on word embedding tools, which can help the models generalize between things like synonyms or words that occupy a similar semantic space. But for the most part, these same tools are not easily available in languages other than English. And this is true even for newer large-scale language models. Even though those non-English state-of-the-art models can achieve great results on tasks in a lot of different languages, their accuracy still lags between 10 to 20% behind English. And those variations and limitations force the developer to come up with new feature sets for every language in question, or to make up for the lack of them with large amounts of labeled data. One way that this has been done is by using machine translation to convert from a high-resource language like English to the target low resource language. And this has been a popular approach, but it's really dependent on the accuracy of the translation model between the language pairs. This can unfortunately lead to a chicken and egg problem because translation models also depend on well-resourced multilingual models and data. So without more effort put into data curation for lower resource languages, we're always going to have this kind of resource limitation. So with that, let's wrap up. Overall, we've taken a view of internationalizing voice-driven applications that requires a much broader scope than localization of static text. Being aware of these linguistic differences throughout the development process is crucial for streamlined product implementation and thoughtful design. Ultimately, we've learned it's critical to design applications with an international and a multilingual audience in mind, because this allows the platform and the process to have the flexibility that might otherwise be overlooked. What really counts in effectively internationalizing a product is its flexibility. We need a data development process that can respect linguistic differences, and we need to work with native speakers to adapt our product to the social context it will be used in. And this can help us create digital assistants that are a benefit to their users and expand access along many dimensions. Being attuned to these differences helps break down another barrier in the communication between humans and technology in our more and more hybrid world. Thanks. And thanks especially to the organizers of the Chatbot Europe conference and to the team at WebEx who have helped us shape some of the ideas in this presentation.